Prime and composite numbers. Prime and composite numbers are two different classifications of natural numbers. Prime numbers. Prime numbers are natural numbers greater than 1 that have only two distinct positive divisors, 1 and the number itself. In other words, a prime number cannot be evenly divided by any other number except 1 and itself. Examples of prime numbers. 2 is the smallest prime number because it is only divisible by 1 and 2. 3 is also a prime number because it has no divisors other than 1 and 3. 5, 7, 11, 13, 17, 19, 23, 29, and so on, are all prime numbers. Prime numbers are fundamental in number theory and have various applications in cryptography, computer science, and other fields. Composite numbers. Composite numbers are natural numbers greater than 1 that are not prime. In other words, a composite number has at least one positive divisor other than 1 and itself. In simpler terms, composite numbers can be evenly divided by more than two distinct positive divisors. Examples of composite numbers. 4 is the smallest composite number because it can be divided evenly by 1, 2, and 4. 6 is also a composite number because it has divisors 1, 2, 3, and 6. 9, 10, 12, 14, 15, 16, 18, 20, and so on, are all composite numbers. Composite numbers can be further classified into different types based on their divisors and properties, such as abundant numbers, perfect numbers, and deficient numbers. It is worth noting that the number 1 is not classified as either prime or composite because it does not meet the criteria for either category. It only has one positive divisor, which is 1. Divisibility rules. Divisibility rules are helpful guidelines that help determine if one number is divisible by another without performing the actual division operation. These rules are based on certain patterns and properties of numbers. Here are some common divisibility rules. Divisibility by 2. A number is divisible by 2 if its units digit is even, i.e., it ends with 0, 2, 4, 6, or 8. Examples. 124 is divisible by 2 because its unit digit is 4. 351 is not divisible by 2 because its unit digit is 1. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Examples. 246 is divisible by 3 because 2 plus 4 plus 6 equals 12, and 12 is divisible by 3. 457 is not divisible by 3 because 4 plus 5 plus 7 equals 16, and 16 is not divisible by 3. Divisibility by 4. A number is divisible by 4 if the number formed by its last two digits is divisible by 4. Examples. 832 is divisible by 4 because the number formed by its last two digits, 32, is divisible by 4. 417 is not divisible by 4 because the number formed by its last two digits, 17, is not divisible by 4. Divisibility by 5. A number is divisible by 5 if its unit digit is either 0 or 5. Examples. 175 is divisible by 5 because its unit digit is 5. 482 is not divisible by 5 because its unit digit is 2. Divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. Examples. 258 is divisible by 6 because it is divisible by 2 and the sum of its digits, 2 plus 5 plus 8, is divisible by 3. 377 is not divisible by 6 because it is not divisible by 2. These are just a few examples of divisibility rules. Similar rules can be found for divisibility by 7, 8, 9, 10, and other numbers. Knowing these rules can simplify calculations and help determine divisibility quickly. Factors and multiples. Factors and multiples are two related concepts in mathematics that involve the relationships between numbers. Factors. Factors of a number are the numbers that divide it evenly without leaving a remainder. In other words, factors are the divisors of a number. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12 because these numbers divide 12 without any remainder. Examples. The factors of 10 are 1, 2, 5, and 10. The factors of 15 are 1, 3, 5, and 15. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. It's important to note that every number is divisible by 1 in itself, so those two numbers are always factors of any given number. Multiples. Multiples of a number are the numbers that result from multiplying the given number by any whole number. In other words, multiples are obtained by multiplying a number by integers. For example, the multiples of 5 are 5, 10, 15, 20, 25, and so on because these numbers are obtained by multiplying 5 by 1, 2, 3, 4, 5, and so on. Examples. The multiples of 3 are 3, 6, 9, 12, 15, and so on. The multiples of 7 are 7, 14, 21, 28, 35, and so on. The multiples of 10 are 10, 20, 30, 40, 50, and so on. Every number is a multiple of 1 because any number multiplied by 1 gives the number itself. Factors and multiples are related in the sense that the factors of a number are also its divisors, and the multiples of a number are obtained by multiplying that number by other numbers. Prime factorization. Prime factorization is the process of expressing a composite number as a product of its prime factors. In other words, it involves breaking down a number into a multiplication of its prime factors. Here's an explanation of prime factorization with examples. Identify the smallest prime factor. Start by dividing the given number by the smallest prime number, which is 2. If the number is divisible by 2, divide it as many times as possible until it is no longer divisible by 2. If the number is not divisible by 2, move on to the next prime number. Repeat the process with subsequent prime numbers. Continue the process of dividing the remaining quotient by the next smallest prime numbers 3, 5, 7, 11, and so on until the quotient becomes 1. Each time you find a prime number that divides the quotient, divide it as many times as possible until it is no longer divisible. Express the number as a product of its prime factors. Write down all the prime factors obtained from the previous steps as a multiplication. The result is the prime factorization of the given number. Example 1. Prime factorization of 24. Divide 24 by the smallest prime number. 224 divided by 2 equals 12. Divide 12 by 2. 12 divided by 2 equals 6. Divide 6 by 2. 6 divided by 2 equals 3. Divide 3 by the next prime number. 3. 3 divided by 3 equals 1. The prime factorization of 24 is 2 times 2 times 2 times 3, or simply 2 cubed times 3. Example 2. Prime factorization of 56. Divide 56 by 2. 56 divided by 2 equals 28. Divide 28 by 2. 28 divided by 2 equals 14. Divide 14 by the next prime number. 2. 14 divided by 2 equals 7. Divide 7 by the next prime number. 3. 7 is not divisible by 3. The prime factorization of 56 is 2 times 2 times 2 times 7, or simply 2 cubed times 7. Prime factorization is useful in various mathematical operations, such as simplifying fractions, finding the greatest common divisor, or determining the least common multiple.